We're going to be looking at key features of functions. Specifically, we're going to be talking about the graph, so we will be using Desmos to look at that information, and it's a lot easier to pick out the information because Desmos already finds key information for you. So the first thing before we even get started about talking about those different features, we got to talk about interval notation. Interval notation is just giving you kind of like you're going from this number to this number. It's giving you the boundaries, okay? If it is included, if a number is included, you are going to use brackets. If the number is not included, you are going to use parentheses. This will make a little bit more sense once we actually look at a graph specifically. So let's talk about some of that stuff based on our graph. Sorry, had to run back to my computer to switch over to a different screen there. So as you can see, I already have a function pulled up here. I have the function, what it is, actually off to the side. That way you don't see it. But just so you can get an idea of what we're actually talking about here. So looking at this, we have some basic information to talk about. First one is domain. The domain, remember, are the x values. How far left do you go? How far right do you go? What I like to do is I like to see the edge of my graph and draw a line on the left and on the right. If I look at this, how far left does my graph go? Now, technically, as you can see here, this graph just keeps going on forever and ever, which means that it's going to infinity. But because it's going down, it's negative infinity. Now I go to the right. How far does this go to the right? Technically, if I zoom out, if I keep zooming out here, notice that just keeps going on forever and ever. Okay, so prime example there, again, it's going towards infinity and a little bit beyond. The range, these are the y values. So again, I go from the bottom all the way to the top and I mark those. Well, how far down does that go? This graph keeps going down on the y-axis, so it's going from negative infinity. Looking at the highest value, it just keeps going on forever as well. So that's positive infinity. Next thing are the intercepts. There are two different types of intercepts. There are x-intercepts and y-intercepts. This is where it crosses the axis. So if I'm looking at the x-intercept, this is where it crosses the x-axis. And I can see I have three values where that actually occurs. That occurs at -2, at 0, and 2. Now the y-intercept, where does it cross the y-axis? There's only one actual value, and that's at 0. Okay? Next, we need to talk about increasing and decreasing. This is just where is the graph going up. That one's pretty self-explanatory. I can see that the graph is going up from my negative infinity to this value. If I click on that graph, I will actually get a point, as you can see there and there. So it is increasing or going up from negative infinity. We only use the x values on this when we're talking about the increasing and decreasing, to negative 1.155. It's also increasing, if I notice here, from positive 1.155 to positive infinity. it's decreasing. So where's the graph going down? The graph is going down in this section. So that's from negative 1.155 to positive 1.155. Again, just a little note. These are only x values. Same thing on these intercepts. Well, I shouldn't say that. That's only the x value. The y-intercept is only the y value. Domain are the x's, ranges are the y. We've got one other thing to discuss quick. And that is, where's the graph negative versus positive? So the graph is negative when it's below the x-axis. Again, we're only using the x values on this as well. So the graph is negative on these portions here that I just marked. So it's negative from negative infinity to negative 2, a union from 0 to 2. Now, notice on all of this, I've been using parentheses. The reason why is because if you look at this, if I have negative 2, that's at 0. 0 cannot be negative, and it can't be positive, so I don't include it. Anytime that you have a infinity symbol, that is also a bracket. Positive values, as you can tell with the positive values, this is where I'm above the x-axis, which I'm following my dots there to differentiate between the two. So it is positive from negative 2 to 0, and a union from 2 to infinity. Domain and range. Domain is left and right. Range is up and down. Intercepts where it crosses the axis, specifically the x-axis or the y-axis. Increasing and decreasing, that one's pretty self-explanatory. How is the graph moving as you go from left to right? Negative and positive is where you're above or below the x-axis. Something to note that you might want to put on here, when it's the numbers not included, you use parentheses, or if you're using negative infinity or positive infinity. Something else to note from this, these points here, these are our mins and maxes. This right here is a relative max, and it's a relative max because in that area, it's a maximum. You're at the top of that hill. Even though this keeps going on forever, it's a max in that area. It's the top of that hill. Kind of like down here, we have a relative min. It's the bottom of the hill for this area. These values here, sometimes these are also called zeros, or it could be called a root. Either or. You'll hear me interchange those a lot. Just kind of depends on what we're talking about. But just so you're aware, the x-intercepts are sometimes called a root or zero. And the last thing we need to talk about is an average rate of change. Now, average rate of change okay, this is basically, it's a slope formula for any line slash curve. Okay, so basically it doesn't matter if it's a line or a curve, the average rate of change is the same as the slope formula. It just looks a little bit differently. If you have a parabola, most people think that they can't use the slope formula. You are using the slope formula, it's just an average, it's just renamed as an average rate of change. Again, notice I didn't put like the subscript of 1 or 2. Just know that these have to be matched up together and these points have to be matched up together. So it really doesn't matter. Just a refresher, If you have a point at 3, 0 and at -2, -5, to find the slope or the average rate of change, I would have 0 minus -5 over 3. I have to use the 3 because I used the 0 first. So it'll be 3 minus -2. I get +5 over +5, which equals 1. That would be my average rate of change. Even though I don't have a picture here, doesn't matter. It's the same concept, whether it's a parabola or a line or some type of curve. Okay? So key features of functions, just looking at mins, maxes, domain, range, intercepts, all of that good stuff, just so you get a better idea of what the graph actually looks like. Again, use Desmos as much as possible.